good hour just trying to figure it out. Because I would get it, but then I don't know, maybe I did something wrong with the algebra or something, and then it would mess me up,
Mm-hmm.
and I'll get a totally completely different answer from the four choices, and I was like, I thought I did it right, I thought I was actually getting it, and then
Hmm.
I got so frustrated, I was like, I just looked there, I was like, you know what, I'm just gonna ask this guardian.
Gotcha. Okay. Well, yeah. That's why we have class. So for those of you joining us can't hear them, they're saying they would look at the video, kind of look at the notes, which both of those are absolute great ways of doing things. Um, Let me make sure that we all understand what the goal is here, right? So, well, let me ask you, Mitzi, what is the goal of of these problems?
To find the thing.
To find the tangent line, I'm going to be a little more specific than that. It's going to be to find the equation of the tangent line. Okay. However, as we saw yesterday when we were doing that local linearization, there could be a tangent line. There's like an infinite number of tangent lines, right? So let's be a little more specific. Where are we finding? At what point are we finding the equation of the tangent line? On this one in particular, it's a 0, -2. Okay. So there's a couple of stages in this. If I were to kind of think it through, step number 1 would be to find the slope. Step number 2 would be to plug that into y equals y1, or y minus y1 equals m times x minus x1. And then step 3 would be to solve for y. So you would have y equals mx plus b. Kirsten, you started off the conversation here. Which one of those 3 steps would you say is giving you the most trouble?
Well, when I would do the problems, I was able to plug in everything and figure out where to go. But when it came to solving the distributing part, not necessarily
When you say the distributing part, do you mean the part where you're manipulating the y minus y1 m, or are you talking about back up here when you're plugging into the limit? Mm-hmm. Okay. So you said sort of combining the like terms? Okay. All right, I'll put a little note here, issue with the like terms. Okay, so it seems like you're kind of you're kind of struggling with the algebra, doing the limit of the difference quotient part. Okay, I've got a note on that. Mitzi, how about you? What's your question?
So what I would do, I would run through this problem, and I was like, okay, I think I figured it, and I
Mm-hmm.
think it was one part where I mixed up with the algebra you said.
Mm-hmm.
It said, do I put this to this? I think I would get confused a lot because it's delta x, and I was like, it was the same thing, and then I would go back to the videos. I have the videos popped up right now. That's why
Okay, that's fine.
yeah,
So obviously you were starting to work on one particular problem, right? You've got a.
so I worked on one of them, and then I was like, I'm not figuring this out. Let's see if there's a different form of problem. Then I would go to a new problem.
I think they're all going to have all of the equations are either going to be something x squared minus, it's all going to be like an x squared x and a number right there, like 3 terms, or maybe just 2 terms.
Yeah, I would just go 1 to 2 terms, or because the first one was 3 terms, I think the first one I got, and then I skipped it. I was like, let me try a different type.
If you can handle the 3 terms, the trinomial, then you can pretty much handle anything.
Yeah, and I couldn't figure it out.
Okay, so okay.
Yeah, I would get a different answer at the end.
How do we like this one? X squared minus 2x plus 1. Yeah, I mean, do we want to look at that real quick? Okay. So, and I'm only going to focus on finding the slope here. Is that okay? Because the question is, once you find the slope, I mean, do y'all know how to plug these parts in? So this is good, and then manipulate, just basically distributing the slope and adding the y1 to both sides. We're good on that. So it's really this first part up here. Am I right? Okay. So if we were to write steps over there, then maybe if we kind of write out here, I would say step number 1 would be write the slope of the tangent line equation formula, right? M tangent equation or formula or whatever. So I'll do that over here. Slope of the tangent line equals the limit as delta x approaches 0. Mitzi, do you want to read off the rest of it to me? Mm-hmm. Okay. That's pretty good. Because I'm going to try to push a lot of this stuff onto you so I can identify if there's a problem based on what you're looking at your notes. Okay? Step number 2, plug in C. Limit as delta x approaches 0. So what is our C value in, we're looking here at number 4. Okay, 2. So f of 2 plus delta x minus f of 2 Barbara, what would you say would be the third step? Mm-hmm. So to plug, when you say it, I would refer, I'm assuming you mean the 2 plus delta x, to plug that into the equation. At the same time, I would maybe also plug this one into the equation, which we can do pretty easily. Okay? So plug in this case, it's 2 plus delta x. You said equation, so I'll use y'all's terminology into equation. Also plug in 2 into the equation. So M tangent. So Kirsten, based on what you were saying, this is not the plugging in isn't necessarily the part that you were having a question with. It was more of once it's plugged in and crazy expand out here, combining. Absolutely. Yep, we can help you with that. But Mitzi, I was kind of under the impression maybe this might be the point where you're struggling with, or you're not sure if when you do it right. Okay, that's great. So when we plug it in, remember, that means basically you say the whole equation, but replace x with, and now here's where I'm going to make a big deal out of this, parentheses 2 plus delta x. All right, so going to you, Mitzi. So we're looking at this equation right here. So, okay, so parentheses 2 plus delta x squared. It's minus 2. Parentheses. Keep going. Mm-hmm. Now, I kind of did a little bit of magic waving of my hands when we dealt with this one before. Okay? I'm okay with that if you know what that trick is. But if you're not okay with that, what I'm talking about, then we need to talk about how to find f of 2. All right? So, Kirsten, you tell me, how would you find out f of 2? Yeah, I could just plug it in like I did right there. I could plug 2 in, and every time I see x, I'm going to replace it with parentheses 2. So it's literally the same thing. I mean, this is the crux of evaluating functions. And now that I'm thinking about it, I think that it would, before we did this lesson, in all reality, it would probably be really good just to spend one day plugging in numbers into functions and plugging in expressions into functions. It would totally be worth one lesson, I think, because that's the part that we're all struggling with, right? Or well, at least I feel like it is kind of an issue. Okay, so I'm going to put a minus here, and I'm going to put a parentheses. Now there is a shortcut here, and you're all going to kick yourself after we see it, but that's okay. But just for the sake of consistency here, let's go and do it. So Mitzi, back to you, since you wanted to know how do I do that. So does it make sense when I say every time you see an x, say parentheses 2? So it's the same process. That's what function notation means. Plug this in to the value. So go ahead, Mitzi, call it out to me. Now I've got a bracket because it's minus this whole thing, right? And we're going to have a big old mess here. So go ahead and call it out to me. We're plugging it into the x in the formula. F of 2 means plug 2 into the formula. Heck yeah, I want you to put parentheses because sometimes it might be negative.
Okay, so parentheses, 2 plus parentheses.
You can just start from start. Got it? Okay.
Minus 2, and then parentheses 2, and then plus parentheses, sorry, plus 1.
Mm-hmm. All over delta x.
I think that's where we're messing up. I think that was putting 2, us putting 2 down.
Mm-hmm. All right. Now now let's go ahead. We'll do a quick evaluate. So step number 4 is going to be evaluate and simplify. Now this right over here is just straight numbers. Okay? 2 squared, which is 4, minus 2 times 2, which is 4, plus 1. So 4 minus 4 is 0, plus 1, so all of that turns out to be, whoops, not 0. All of that turns out to be 1. Which is the y value when x is 2. Okay? So what's the shortcut for finding what f of 2 is? Just look at the function and look at what the y value is. I feel like we're still kind of shaky on that. Okay, so like if you were to make a table, right, of the x's and the y values, right, at 2, the y value is 1. But in calculus, we normally don't talk about x's and y's. We talk about x's and f of x. Okay, so, all right, so we've got a 1 right there. Slope of the tangent line equals limit as delta x approaches 0. Going back to you, Kirsten, do we feel like maybe it might be an issue with the squaring of binomial expressions?
No.
Okay, Mitzi, how about you? Squaring of a binomial expression? No. Okay, then what do you think it would be, Mitzi? Nah.
Okay, 4 plus 4 delta x plus delta x squared.
Right, and I always put that in parentheses because otherwise it can look like, if you just write delta x squared, then it looks like it's x squared. And so I know it's sort of like an extra little step to put the parentheses around there, but I highly recommend it. This next part here might be a place where you miss. Notice it's minus this whole term, okay? So you could write minus and then put like big brackets and then figure out what this whole term is. Or you could treat that minus as a negative 2 and distribute that negative 2. So negative 2 times 2, so negative 4. Negative 2 times delta x, so minus 2 delta x. Plus 1, and this was a minus 1. Now we do like what? Exactly. Now that was a thing. It's Kirsten. It's fascinating to me. It's kind of, nerdy math teacher stuff. That you were able to utilize the vocabulary word like terms, and yet you said that that's a thing that you kind of struggle with. Normally, students who are who struggle with like terms can't even like use the phrase. They're not even like give it a name. But you gave it a name, and that's where we're at right now. So what is, obviously there's some question or uncertainty in your head with respect to that. What is it? Okay. Well, let me take you in the Wayback Machine here to Algebra 1. What does like terms mean? How would y'all define like terms if you're teaching Algebra 1? Like, for instance, is 4 and 4 delta x, are those like terms? Why not? They don't have the same variable. Okay, well, what about, so like terms obviously has some idea where you've got the same variable, but, all right, challenge accepted. What about the 4 delta x and the delta x squared? Those both have the same variable in it and don't have the same exponents. So like terms are same variables to the same exponents. This one has a delta x, which implied to the first power. This has a delta x squared, not like terms. But there are some things that are like terms, such as what I would call these constant terms. So I kind of do circles and then I do boxes, taking me back to my Algebra 2 days. I also have a minus 4. So notice all of these terms right here, they're constants. We kind of talked about constants yesterday. Because they don't have any variables. And what's really cool, plus 4 minus 4 plus 1 minus 1. Yep, so they're all gone. Goodbye, 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 goodbye. I'm only left with 3 terms left, 4 delta x, a delta x squared, and a minus 2 delta x. Do you see any of those that are like? Maybe the 4 delta x and the minus 2 delta x. So I use boxes around them, and I've included in the box, I make sure to include the sign, the plus or minus that's in front of it. Just some Goddard algebra techniques. Slope of the tangent. It's very likely, because there's only a certain number of problems that can actually be generated on this homework, that someone has this exact problem. I don't know if any of y'all did. But. Okay, so Kirsten, 4 delta x minus 2 delta x is what? So 4, it's 4, a good question. So maybe this is your issue. So all you do is you just look at the coefficients, plus 4 minus 2. So it's 4 minus 2. Think of it, instead of delta x, as apples. 4 apples minus 2 apples. Now, does that answer your question about... So what do you know now that you were maybe unsure about before?
It might be the same exponents part. I felt maybe it's also because I was constantly doing some that I kind of was thinking about the exponents. I was like, can I put these two together? Can I not put these two together?
But yeah, in these problems, since I've given basically, I mean, I'm not giving you a wide variety of problems. Every single one of these are either quadratic binomials or trinomials. And we're still applying to the same formula every single time. So you're going to get to a point pretty much in every single one of these where you're going to have a delta x, you're going to have a delta x squared. And the delta x squared can't combine with the delta x. That's pretty much it. So then we've got the plus delta x, still in parentheses, squared. In all of these, we also get to a point where we're going to need to factor out a delta x.
Why can't I do
It's the magic of the math teacher. That's just, it's sort of like the tech support guy. You know, well, it's not doing it now that you're here, you know, kind of a thing. You know, you have someone come over to help you out with the computer program.
Right now, like, I got on, like, I did it,
Mm-hmm.
because I, like, left by myself. I figured it out. Like, he basically guided to, like, the first half.
Yep.
It's like, why? You know, why it's not, my brain is, like, not.
Yeah. So let this be a lesson to you to learn about yourself and things like that. Number one, don't say, oh, I'll take care of that Friday after school or Thursday after school. If I don't understand it, I'll just watch the videos. Okay? Literally coming to class with questions can be very helpful. Also, as much as you understand it when I'm doing it, there's nothing comes close to you actually kind of forcing yourself to do those steps on your own. All right, so we normally factor out a delta x, in which case then one of those cancel. And then when I'm looking at this, y'all tell me what would step 6 be, so to speak. Yeah, direct substitution for the of 0 into delta x. Direct substitution. So that's just going to be 2 plus 0, which is 2. So what the heck does that mean, 2? What is, go ahead, Robert. Slope of the tangent line on the equation f of x equals x squared minus 2x plus 1 at the point x equals 2, 1. All right? So that's the 6-step process to solve the step 1. Syra, the ladies were asking some questions just about some homework. We're identifying problem areas. And, you know, y'all should feel in good company. These are the same areas that every calculus student always struggles with. Namely, let's give a name to it, plugging in this expression into the function and then simplifying it down to something workable. But when I look at that actually doesn't look too bad, right? Okay. We're going to stop the video, but then we're going to pick up right where we left off. So stop the video.